Let's talk about hydrates. Hydrates are ionic compounds with water associated with them. The water molecules are incorporated into the solid crystalline structure. Here's an example. CuSO4 dot 5H2O, which is otherwise known as copper 2 sulfate pentahydrate. Now the penta comes from the 5 in front of the H2O. That's how we get pentahydrate, 5 water molecules for every 1 formula unit of copper 2 sulfate. Strong heating can evaporate the water that's part of the crystalline structure. When water is removed, the result is an anhydrous, in other words, without water, salt. So here we have a crystal of copper 2 sulfate pentahydrate, and we can see that it's hydrated because in this sample it has a blue color associated with it. Over here we see some of the white substance, which is the anhydrous salt of the copper 2 sulfate. So the copper 2 sulfate pentahydrate with all the water removed, that's why we call it anhydrous, without water. And then someone put a drop of water onto this sample, which basically rehydrated the sample and turned it back into blue, just like we see over here with this hydrated sample. So the white part of the sample is the copper 2 sulfate without the water, and the blues part of the sample is the copper 2 sulfate pentahydrate with the water. An 11.73 gram sample of CoCl2 dot X, which is what we're going to solve for, H2O, is weighed, heated to drive off the water crystallization, cooled, and reweighed until constant mass 6.410 grams is achieved. Calculate the value of X. So we're trying to see how many water molecules are associated with this 1 formula unit of cobalt 2 chloride. So we have 2 pieces of information here. We have our hydrated sample mass, which is 11.73 grams of cobalt 2 chloride with some number of water molecules associated with it. And then we have basically an anhydrous sample. And that is the mass of the sample when all the water has been driven off and all that remains is cobalt 2 chloride. And that is 6.410 grams. So the first thing that you're going to do is subtract these two. The sample with the water in it, the sample without the water in it, to basically figure out the mass of the water. And when we do that, we find that the mass of the water is 5.32 grams of H2O. So that's always going to be your first step, to subtract the hydrated sample from the anhydrous sample and get your mass of water. The next step is to convert your mass of water, in other words 5.32 grams of H2O, into moles. So I'm going to set up my problem here. I know that there's 18 grams of water in 1 mole of water, 1 mole H2O, and I'm going to find the moles of water. And the next thing that we're going to do is find the number of moles of anhydrous salt that remains. So 6.410 grams of CoCl2. So I'm also going to convert this into moles. So 1 mole of CoCl2 is equal to a gram formula mass of 129.79, if I was getting really specific, grams. Okay, so if I convert grams of water into moles of water, I get 0.295 moles of H2O. And if I convert grams of cobalt 2 chloride into moles of cobalt 2 chloride, I get 0.04938 moles of CoCl2. Alright, so all I've done, to summarize, I have my hydrated sample, I have my anhydrous sample, the sample with all the water removed. I subtract the two and I find the mass of the water. I convert the mass of the water into moles of water. Then I take the mass of the anhydrous salt and I convert that into moles of anhydrous salt. The last thing that I'm going to do is I'm going to take the moles of water that I found and I'm going to divide that by the moles of anhydrous salt. The moles of anhydrous salt, using the two values that I just calculated up here. Because in a perfect world, I'm going to get a nice whole number that I can use to represent x. So I'm going to have 0.295 divided by 0.04938. And if I do this, I get 5.97, which I can basically round to 6. So that 6 represents my red X in the top problem. So if I was to write this out, including the 6, it would be COCl2.6H2O for my final answer, saying that for every ionic compound of cobalt-2 chloride, I'm going to have 6 molecules of water embedded in the crystalline structure to represent that it is hydrated. So if we look back at this problem, you'll notice that they use the term constant mass. So what is it meant by the term constant mass in the question above? As a hydrate is heated, the water in the crystalline structure starts to evaporate from the salt. This is observed as the mass is decreasing. So we're going to see a decrease in mass. Heating a hydrate to a constant mass means applying heat until the mass stops decreasing and is the same after repeat massing. As a result, only anhydrous salt remains. So we're going to take our hydrated sample, apply some heat, and keep on heating it until, as we weigh it each time, we find that the mass remains constant. So that's what they mean by constant mass.